Hello, everybody. Hello, Mary, Charlie, Stefan.
Hello. Hello.
Hi.
And today is finally the day, Mary. We've been talking about it for like 9 months, I think, already.
Yeah.
This joint event between the ChicagoJUG and the Montreal user group. And thanks to you, we have two great speakers for today.
Thank you.
Let me go through the little presentation of the JUG activity, and then I will let it to you, Mary, and then we would have our two presenters make the presentations then.
Sure.
So let's start right there. Okay. Today we are hosting Stefan and Charlie, both from Oracle and both engineers on the OpenJDK projects, G1 to Infinity and beyond, and also recent Java performance musings will be their two presentations for today. A quick note about the team organizing the Montreal Java user group. Of course, you all know Henri, Rohan, Xavier, myself, Marion, and David. We are super thrilled today to be hosting this event. I would like also to add some quick notes about our sponsors. Big thank you to Banque Nationale, Adaptive, and Aditya. If you want any information about what we do with the sponsoring, usually we buy stuff for the DevOps for Kids Association for robotics and also workshops for children. But if you want more info and if you want also to participate and become a sponsor to the Montreal Java user group, please send us a note to info@montrealjug.org. I would like also to introduce our next event is going to occur this month on Tuesday, the 26th of October at 12 p.m. EDT. It will be Bruno Borges from Microsoft talking about how Microsoft actually embraces OpenJDK and how they use actually JLink for creating custom runtime for Java applications. Also, the month after, so this is going to be in November, en français s'il vous plaît, initiation au développement de plugin IntelliJ with Jonathan L'Hermitage, who will be joining us virtually from Lyon, France. Our guest speakers are Stefan and Charlie Hunt. I will also, Marie, let you introduce your jugs right now. Just notice, please don't actually leave right after presentations. Why? Because we are going to do actually a raffle to win 2 IntelliJ licenses, both from the Montreal Jug side and from the CJUG side. Over to you, Mary.
Thank you. Thank you so much, Anthony. Thanks for the great introduction. And also, again, welcome Charlie and Stefan. And we've been waiting for this day for so long. So it's kind of really excited. And anyway, it took me some time to get my stuff set up. So let me share my screen. Let's see. It's my Chrome tab. Here we go. I think. Okay, everybody can see my slides, right? The Chicago Java Users Group. We have this template, so I'll be quick, kind of go through that. So welcome, everybody. And just wanted to kind of welcome everybody and remind you that for Chicago Tech Slack, you can all sign up for it. It's not just for Chicago. It's kind of open to all. We also have Java off heap. And then also please join us on the meetup.com. And again, we're very happy to have the Montreal Jug with us today. So. And follow us at CJUG for our Twitter. And also, we have our chat channel on Discord as well. So it's also on our meetup page. So please join us, for the discussion. And Charlie and Stefan, if you'd like to join that for more conversations after, you're welcome to. And then some quick community info too. CJUG is a community partner of the following groups and events. Ongoing is the Virtual Jug North America. Then there's also on October 23rd and 24th is MapCon. They would like us to help them advertise, even though I think most of us do not speak Mandarin, and I speak kind of broken Mandarin. So they like to invite us. There are some free tickets too, if you like to be attending that. It's all virtual. Then there's October 28th is the all-day DevOps. It's 24 hours of nonstop talks. So let me know too if you like any kind of special deal too. I have that. And then December 8th to 10th in Chicago, we'll have an in-person conference, jconf.dev. So please consider joining us. And for CJUG, and now we're extending to members of the Montreal JUG, please use 20% discount code over here that I'll be sharing this slide deck too, so you can look at it after too. Upcoming meetups and events on October 28th, and in-person and online hybrid meetup, we'll be having Pratik from Azul. That this will also be part of the Fuji Java 17 tour. Upcoming meetups too, in actually in more November now. It's will be Axon IQ. They will be talking something on event messaging and Fusion Auth on JSON Web Token. And we're still working on some meetup that we'll be having. So if you're interested in speaking, send us email at present@cjug.org. Is welcome to everybody too. And Jobs Board, we have a CJUG group on LinkedIn. So please consider joining if you're interested. Then gold sponsor for CJUG is JFrog. And now just a quick introduction, right? Again, we have Charlie Hunt, quick thing, Chicago's very own Java performance guru. And Charlie did the last talk like 5 years ago. So we're so happy to have you back again. And then he's a principal software at Oracle. And from the very early days of Java at Sun and JavaSoft, he has led performance work also at Salesforce and Motorola previously. He's also principal author of the Java Performance Book 2011, right, book on Amazon Book Club. So essentially, here is kind of printing out kind of strange. But anyway, I just wanted to put a quote that James Gosling has highly recommended this book. So the definitive masterclass in performance tuning Java applications. If you love all the gory details, this is the book for you. So sorry again for the formatting. And now we also have Stefan Johansson. He's a principal member of technical staff, a HotSpot GC engineer at Oracle. He was previously with Oracle BEA, and your projects previously included JRocket Virtual Edition, a single-purpose OS made for running Java, and also InfiniBand messaging for Java and coherence. So with that, I wanted to welcome again Charlie and Stefan. This stage is all yours. So. Okay.
Thanks, Mary. I will start off, and I will start by sharing the screen. So hopefully you should see some slides by now. I can see you, so if you don't see any slides and don't hear me, please speak up. Yeah, as Mary said, my name is Stefan Johansson. I've been at Oracle for more than 15 years now. The last 8 I've spent on GC and mainly G1. And as Mary mentioned, prior to that, I was working on other JVM-related projects. But yeah, the last 8 years, I've mostly been focusing on G1. And today, we're going to talk about the progress we've made in G1 since JDK 8, basically. I've had this presentation, done this presentation a few times before, so some of you might have seen some of this content, but I've prepared some bonus slides for the end, so everybody should get something new at least. Yeah, let's start off with the agenda for today. I'm gonna do a quick intro to garbage collection in OpenJDK in general, and then look a bit closer at G1, so we know a bit what we're talking about. Focus most of the time on the progress made in G1 since JDK 8, but then also look a bit at the future in the end. The main goal with this presentation is to show all the great progress we've done with G1 and also with the whole Java platform, and hopefully encourage people to move forward to a newer JDK version. Yeah, let's start off with GC in OpenJDK. GC is not only about reclaiming memory. To be able to reclaim memory, you first need to hand it out. This is handled more or less the same way, regardless of which GC collector you use. So the Java threads request memory to allocate from. We call that TLABs, thread local allocation buffers. Once a Java thread has a TLAB, it can do a very efficient allocation by just bumping a pointer and filling out the object. When the TLab is full, the Java thread then requests a new TLab, and the GC satisfies this allocation until it can't do that anymore. And then it's time to do the reclamation. And doing reclamation in an efficient way, that's what is handled differently between the different collectors that we have in OpenJDK. They all use different strategies to try to serve different use cases. There is, of course, overlap, but yeah, we have different collectors for different use cases. Let's take a little look at a few different strategies that you use when you develop a garbage collector. There are, of course, a lot of those, but I just want to mention a few that kind of will help us better understand this presentation. So first of all, in OpenJDK, all the GCs are what we call tracing collectors. So what that means is that we determine liveness by tracing the object graph. So we start off with a well-known set of roots, for example, thread stacks and objects on those, and then we follow references from the well-known roots to figure out what objects are live. So there is no reference counting or anything like that going on in OpenJDK to determine what is live. Then another thing to consider is if you want to do most of the work stopping the world, so that means while the Java application is not running, or if you want to do it concurrently with the Java application. Traditionally, for example, Parallel GC is doing all the work stopping the world. So all the work is done while the Java applications are stopped. The new low latency collectors, on the other hand, they do everything concurrently, more or less. And G1, which we'll look closer at today, is kind of a mix between those two. Having a collector that is generational is in many cases also important and a good thing to avoid having to collect the whole heap all the time. So in OpenJDK, the generational collectors make use of two generations, the young generation and the old generation. All new objects allocated by Java threads end up in the young generation, and the young generation is collected at every GC. If objects are surviving a few young collections, they will be promoted to the old generation. And as the old generation fills up, at some point, you will have to collect the old generation as well. When deciding a GC algorithm, you also have to decide which focus, what use cases you want this collector to work best at. There are, of course, a lot of things and aspects to think about. Three that we talk a lot about is throughput, latency, and footprint. With throughput, we mean the raw number of transactions that you can complete in a set amount of time. Latency is more like the time it takes to complete one transaction. And footprint, with that we mean the overhead caused by the GC algorithm. For example, extra native memory needed to do the garbage collection. And we will look more at those a bit further in this presentation. Currently, we have 5 supported collectors in OpenJDK. I won't talk about them all today. As I said, we're going to focus on G1, which is now the default GC in OpenJDK. Up until Java 8 or JDK 8, Parallel was the default collector. Parallel has a pretty strong focus on throughput. It has good average latencies, but if the old generation gets filled up and you have to do a collection of the whole heap, you can suffer pretty bad worst-case latencies. So that was one of the reasons to go with G1 as the default, to avoid those worst-case latencies. Yeah, so let's head over and look a bit closer at G1. As I kind of mentioned, the basic idea with G1 is to have a balance between latency and throughput, not focus only on one of those two, but try to be really good, but not optimal at both. The big thing is to avoid those worst case latencies that we see with Parallel if you have to collect the whole heap. To avoid this, there are basically 2 main attributes of G1 that makes this possible. And it's that G1 is region-based and it supports concurrent marking of the old generation. Being region-based basically means that we divide the heap up into a fixed amount of regions with a fixed size. Those regions can then either belong to the young generation or the old generation. or of course be free if they aren't allocated yet. Then we have, as I said, concurrent marking of the old generation. This means that we can decide liveness in the old generation without having to stop the Java threads. So even if the heap is really large, we can figure out what is live in the old generation without having very long pauses. Those two things together makes it possible to do what we call mixed collections. Mixed collections are collections where we collect both the young generation and a few regions from the old generation. This way we can avoid to collect the whole old generation at once, and by doing so avoid the very long worst case latencies. Another big part of G1 or a big goal is to make it easier to tune than some of the garbage collectors that have been around in the past. The main tuning knob in G1 is the pause time goal. So the first thing you should try to change if you want to change the behavior of G1 is to look at the pause time goal. The default value is 200 milliseconds, which has proven to be a pretty good default, giving both good throughput and fairly okay latencies. If you want to focus more on latency, you turn this value down to a lower value to get shorter GC pauses. And on the other hand, if you want to focus more on throughput with G1, you can turn this value up. So the current status for G1. G1 was added in JDK 6, but support wasn't added until JDK 7U4. In the JDK 8 timeframe, G1 became much more stable and mature. We did a lot of big features. For example, we added class unloading after concurrent mark, which basically made G1 able to unload classes without having to do a full GC. And doing full GCs is something that G1 tries to avoid by doing the mixed collections. So in a well-behaved application prior to JDK 8, you couldn't get any class unloading happening without forcing a full GC. So pretty important features going into JDK 8. All those good features and all the performance work, the stability work, made us take the decision in JDK 9 to make G1 the default. Some people thought that this was a very bold decision, but we felt that the balance between latency and throughput, the fact that we put more resources into G1, and the potential that we saw made it a good decision. And looking back, I think it was the right decision. Now people get the benefits from G1 just by using Java out of the box. So now let's head over and look at the progress we've made with G1 since JDK 8. Yeah, we've done a lot of work. It's more than 1,000 enhancements that's gone into G1 since JDK 8. It's both really large features, but also small cleanups, small fixes that make things more efficient. But all those things together have really made significant improvements to the overall performance of G1. And it's not just like we've improved latency or throughput or the footprint. We've improved across all areas. And one big thing to be able to do this is that we've reevaluated old design decisions, and by coming up with new solutions, we've been able to cut away some of the old trade-offs that were done for G1. So yeah, as I will now show you, we've improved quite a bit over quite a few areas. But let's start looking at throughput. We've done a lot of work to improve the throughput for G1. I'm going to mention a few of them. One big thing, if you're running on big systems with multiple NUMA nodes, is that we now have a very NUMA-aware implementation of G1. In the past, G1 had some basic NUMA support, but since JDK 14, G1 will now try to allocate and keep memory local to the thread allocating the memory the first time. On systems with many NUMA nodes, this has shown to give really good performance boost when it comes to throughput. So if you're on such systems, you should try G1 in a new version. It's really good. We've also worked hard on making sure that the concurrent work is done as efficiently as possible. So doing the concurrent marking efficient, doing other concurrent parts, very efficient, but also looking to make sure that we don't schedule concurrent work unless it's actually really needed. So one thing here is that we can abort the concurrent mark cycle if we realize that a YUG collection has already taken care of the reason that we started the concurrent cycle. For example, if we started concurrent marking because we need to handle very large objects or things like that, we can now abort that if we realize that the YUG collection already took care of that. And this also helps the throughput by not using the CPU resources for doing unnecessary work. The last point here, adding a parallel full collection for G1 was done in JDK 10, and that can also be seen as a latency improvement because it improves the worst case latencies. But since the collector also gets a lot fast, the whole collection gets a lot faster, will give it more time to run Java, so it becomes the throughput feature as well. It also helps if you want to tune G1 to a more throughput oriented way, because then you might run into more full collections, and having a parallel version of that makes G1 more on par with parallel GC. So let's take a look at how this looks for a pretty well-known benchmark in the Java world. I'm using SpecJBB 2015. As I said, it's a standard benchmark. Here it's run with a 16 GB heap and without too much tuning. I run with large pages and I run with NUMA enabled, just so we see the performance boost given by the NUMA feature. When you run SpecJBB 2015 in compliant mode, you get two results, one raw throughput metric and one metric which is throughput under latency requirements. The measurement we look at here is the raw throughput one. So as you can see in JDK 8, parallel was ahead of G1, not too much, but a little. But going forward through JDK 11 and JDK 17, the performance improvements in G1 now makes it a lot faster than parallel in JDK 8. To be fair, parallel has of course also become better. So in JDK 17, parallel is better than it was in 8, but it's actually not as good as G1. It's not far after, but G1 is ahead. I should also mention that these improvements are not only from the things we've done with GC. The whole Java platform has become much more efficient over the last few releases, and things like compiler improvements also help this result. But making sure we keep out of the way with the GC, making sure that the pauses are short and the concurrent work is efficient really helps the overall throughput as well. Yeah, let's head over and look a bit at what we've done for improving latency. When it comes to latency, it's basically two parts. It's, of course, keeping the pauses short, but it's also making sure that they are predictable so that we can keep the pause time target set by the user. To make sure that the pauses are short, we've worked really hard on improving the parallelism. So we've made sure that almost all the phases in the GC can be scaled up to use multiple threads if needed. This wasn't the case back in JDK 8, where a few phases were always done single-threadedly, and this is really bad if you scale up the heap size. We also worked hard on making sure that the processing itself is efficient. So it's everything from processing the internal data structures of G1 to process Java lang references. So yeah, we worked hard on making sure that everything is done as efficient as possible. When it comes to the predictability side, we've worked hard to make sure that the pause time predictions are as good as possible, so that we can decide how many regions we're able to let the Java threads allocate before doing a collection. Because if you don't predict this in a good way, you will have a very flaky pause time curve. So you'll go up and down. Another thing to be able to keep the collections under the pause time target is a feature that we call abortable mixed collections. Abortable mixed collections is a way to not collect all the old regions in a mixed collections that you planned to collect. So if you realize that, oh, we're about to break the pause time target, you can be able to abort the last part of the old regions in that collection. So this is really good to help keep the pause time target as well. let's look at the SpecJBB results from the latency perspective. So this is the latency or throughput with latency requirement metrics that I mentioned. Still with the same setup, 16 gig heap, not too much tuning. The difference here is that the improvements we see are mostly caused by the changes that we've done in G1, because a lot of this score is due to GC pauses, because those affect the latencies the most in this benchmark. So as you can see, in JDK8, parallel was better than G1, even from a latency perspective. So it was the right thing to have parallel the default back then. But going forward, G1 goes past parallel and is now way better than parallel. Even if parallel has also improved, it's not as good as G1. One fun thing to show here is also how easy it is to tune G1 to give better latency scores. So the bar to the right here is G1 with a pause time target of 50 milliseconds instead of the default 200 milliseconds. And by doing that, we can push the latency score even higher. If we do this, we will get a lower throughput score. So you need to make sure that this is what you want to do. You need to trade some throughput for better latency. But that's pretty usual when it comes to GC, that you have to trade something for something else. Let's also look a bit at how the pause times has progressed over these releases. I'm still using SpecJBB 2015, but not the compliant run. Since the compliant run is done with a varying load, it's not fully deterministic. So comparing pause times between runs isn't totally fair. So instead, I run at a fixed injection rate at about 60% of the max, still using a 16 gigabyte heap. But doing this, we can see that even in JDK8, the pauses are well below the pause time target of 200 milliseconds. But going forward in JDK11 and JDK17, we've been able to push the pause time down pretty amazingly. And even the P99 pause time is just above 100 milliseconds. And also to show, if you want to do some tuning, if you add the pause time target to be 50 milliseconds, we're able to push the average down below this number. But we still have some work left to do to be able to even push the P99 pause times down below this limit. When we're talking about low latency, we have to mention the new low latency collector that we are building at Oracle, ChicagoJUG. One of the main goals with ChicagoJUG is to provide sub-millisecond pauses. And with JDK 17, this is achieved for a lot of different benchmarks. SpecJBB 2015 is no exception. And as you can see, the pause time are extremely impressive here. So the average is, way below a fraction of a millisecond. The P99 pause is around 0.2 of a millisecond. So really impressive. The way to achieve this is to do all the heavy work concurrently. So everything from scanning the thread stacks to doing the actual compaction is done while the Java application is still running. So if you care a lot about low latency, you should certainly check ChicagoJUG out. It is really good from that perspective. The last part I want to talk about when it comes to improvements is footprint. And this is something that in the past, in the JDK8 timeframe, we heard a lot of problems with people running G1. They got good latency and things like that, but the memory overhead seen with G1 was pretty bad. The main reason for this was the remember sets. And you might ask yourself, what are remember sets? That's a good question. The simple answer, it's the internal data structure in G1 that is needed to be able to collect the region. So for young generation regions, you always need to have remember set. For old regions, you need to have remember sets when you're about to do mixed collections. In the past, before JDK 11, we always kept all remember sets around. So even if we were not doing mixed collections, we made sure that the old generation remember sets were up to date. And this really wasted a lot of memory. In just a minute, I will show you just how bad this was. But in JDK 11, we added a feature called rebuild and remember sets concurrently, which basically is after the concurrent marking, we rebuild the remember sets for the old regions that we will collect in the mixed collections. So we don't have to keep them around during the young only phases. And yeah, this gave some really good improvements. After that, we also worked hard on trying to improve the ergonomics around the sizing of the remember sets. Since we don't have to keep them around the whole time, we could shrink them down and really push the memory usage down quite a bit. I also want to mention that we've improved the way G1 can return memory to the OS. Prior to JDK 12, G1 could only return heap memory after a full collection. And as I mentioned, G1 tries to avoid full collection as much as possible. So that basically meant if you grow the heap, you will never shrink it and return memory to the OS. We changed this in JDK 12, making it possible to return memory after the concurrent marking as well. This, together with the possibility to schedule periodic concurrent cycles, can really help out running G1 in memory-constrained environments, and if you have an application that might have a idle state or something like that. So that's something to try out. But yeah, let's take a look at how we improved the remember sets. Here I'm not using SpecJBB 2015 because that's a pretty nice benchmark when it comes to having a lot of objects in the old generation. So instead I'm using a stress test that we call the Big ROM tester. I'm running it with a 16 GB of heap, and it really stresses the internals of G1. As you can see in JDK 8, the extra native memory usage that we needed to be able to cope with this benchmark was around 4.5 gigabytes. So more than 25% extra memory needed for a 16 GB heap. That is really bad. I totally understand people complaining about that. With rebuild remember sets concurrently in JDK 11, we were able to push this down to around 3 gigabytes. Still not very good, but a lot better. But the great improvements comes after that with the work with sizing and making sure that we only keep exactly the regions remember sets that we actually need around. So in JDK 17, we're down to below 10% overhead, which is really nice, I think. And the good thing here, we didn't have to trade away anything. The throughput and latency is also better. So just for fun, the average pause in JDK 8 in this stress test was around 2 seconds. So that's 10 times over the target. Really bad. In JDK 17, we're still above the target, but we're down to around 300 milliseconds. So we've improved quite a bit when it comes to the pause time in this benchmark as well. So let's take a very quick look at the future. So we, of course, want to keep improving G1. We know of a lot of things that can be made better. We're currently looking at making usability improvements, making sure that G1 behave better in cloud environments and things like that. We also want to improve the overall throughput of G1. And one thing that we know can be improved is the write barriers. Compared to parallel, for example, the G1 write barrier is quite expensive. So we're investigating if we can improve on this. And we also want to do even further footprint reductions. G1 is still behind parallel when it comes to footprint. And we have ideas so that we might be able to go down to the levels of parallel. We already have some things in JDK 18 that will help. So it's looking good. So what are the key takeaways from this presentation then? Well, there have been massive improvements to both G1 and Java as a platform since JDK 8. So if you're running an older version of Java, I really encourage you to try out something newer. And if you are not running G1 because in the past maybe it didn't perform as well as you had expected, I think you should try it out now in JDK 17 because it has gotten a lot better. We also have a lot of exciting features in the pipe. And yeah, those features together is how we're going to push G1 to infinity and beyond. This is it for the main part of this presentation. I have some bonus slides, and I think we should have time to do those. But before heading into the bonus section, do we have any questions? I'm not able to see the chat because I have this big. Maybe if I can. This is good. I'll end the presentation and I'll see if you have any questions. No questions in the chat. Do we have any other questions? I guess not. Then I will continue here.
Wait, Stefan, I think there was just a question from Vasil on the chat.
Cool. I wonder why I can't see it. I see a private chat.
No, you can go to the normal chat. He just posted it. Wait, I think I even can. Yeah, can you see it now? It's in the main screen.
No. I'm actually not an expert in CMS. I never worked on CMS that much, but the card tables, we have card tables for G1 as well, and I expect that they are used in the same way. So card tables are, I guess, if the remember sets is a way to not have to scan the whole card table. That's kind of a simplified view. So instead of having to scan the whole card table, we record if something is dirtied in the card table, we put that card into the remember set so that we don't have to look at the whole card table to figure out which cards we might have to scan to get the references into the collected generation. So it's not exactly the same thing, but they are connected. I'm not entirely sure how CMS handled that, if they had something similar to the remember set, or if they scanned the whole card table to figure out where to find things. Hope that's a satisfying answer.
Thank you, Stefan. I think we have other questions. Actually, in the chat, there is one from Mathieu. He's wondering if the code for the stress test is public.
I would love to answer yes. We've looked at doing it public in the past. It is public in that sense that it's attached to a JDK bug, but we can't make it part of the. I'm not sure how much. Yeah, I'm not a lawyer. That's the short answer. But there are technicalities because we don't know exactly who the author that made this stress test, who that is, who wrote the first version. So we can't make it part of the OpenJDK, but it is available in a bug. I am not entirely sure, but I would assume that Googling for Big ROM tester would render that bug. And the source code, it's pretty short, and it's basically an in-memory cache that updates, deletes, and reads entries in the old generation, which causes a lot of inter-region pointers, which is really problematic for G1 and for the other collectors as well. To tie back to the last question, that would render a lot of entries in the card table that needs to be scanned. So yeah, it's a pretty good stress test to see problems in your GC. Hope that's a satisfying answer.
Well, thank you, Stefan. And we have a last question from Anbu.
Yeah.
He was wondering what are the tools developers need to know to monitor how GC works in Java?
Well, tools. Yeah, I mean, I always start with looking at the GC logs. Then, of course, we have JFR, which also have some really good events for knowing what's going on with the GC. Another tool that I really like is the native memory tracker, which is, if you turn that on, you can use J command to ask the running Java process how much native memory is your JVM using. And you'll see how much heap memory you have committed. You'll see how much the GC subcomponent is committing. You'll see how much the code cache is committing and things like that. So native memory tracker is also nice, but otherwise, looking at logs using JFR, that's mostly how we do what I use when looking at performance, things like that. And of course, you can, if you run into hard issues, you might have to use other types of profilers like perf in Linux or vtune or things like that. But yeah, I think what you should start with is the GC logs is the first thing. JFR and native memory tracker is next here.
And if you have time, Stefan, there is a last question that just popped
No
out.
problem.
There it is.
So no, not the hard limit or cutoff. It's just a goal. The option is actually called max GC pause millis, which suggests that it is a hard max. But yeah, that option has been there for a long time. We've talked about changing the name to more show that it is a target. It's not a hard limit. But G1 really tries to keep the pauses under this. But we don't provide any guarantees. Cool. Yeah, so unless we don't have any more questions, I think I will do my bonus slides before letting Charlie take over. They should be fairly quick. So you can see this, I hope. So I call this part GC to infinity and beyond. And this is basically more or less the same scores that we've looked at, but for parallel and ZGC as well. So these are the three GCs that we focus our development today. We, of course, also have serial that we support at Oracle, but we're not doing a lot of new development on serial. Serial is still good if you want something with very low memory overhead, where you don't expect too much GC work to be happening, or if you have a really small heap, then serial can be a good choice. But yeah, parallel, G1, and ZGC are the collectors that we are focusing on. And this chart is showing the collectors compared individually. So we're not looking at raw numbers, but the first version of a collector is what's the baseline. So as you can see here, parallel has also improved quite a bit when it comes to throughput since JDK 8, and not as much as G1, but it's not far behind. And if you want to tune G1, you can in many cases achieve better throughput than G1, but out of the box, G1 is doing a pretty good job. And the numbers with G1, I won't mention these a lot because it's basically what you saw already in the presentation, but presented in a different way. When it comes to ZGC, the raw throughput is not as good as with parallel in G1 in all setups. But if you give ZGC enough headroom with the heap, it will be really good when it comes to throughput as well. And as you can see, between JDK 15 and JDK 17, the throughput improvement is almost as big as it was for G1 between 11 and 17. So they are doing some really good work with ZGC to improve the throughput as well. And they're currently working on making ZGC generational. So yeah, that will improve the overall experience of ZGC as well. If we then look at latency for those three collectors, we can see that G1 is the one that's improved the most compared to itself. Parallel is not far behind, while the improvement for ZGC isn't as big between 15 and 17. And that might suggest that parallel or ZGC isn't that good when it comes to latency. But the fact is that ZGC was so good in JDK 15 already, so that the improvements done to 17, even though the pause times has gone down a lot, the latency score can go up much more. So even if you the GC pauses get this short, there is still application latencies and other things that still take time. So if we then look at pause times instead, again, a bit strange, but normalized to the pause time in the first release, we can see that for parallel and G1, we've done great work. We've cut down the pause like 30 or 40%, but it's not close to ZGC, where we see like 10x improvement, which is it's impressive. And the big reason here is that in JDK 15, ZGC had to still scan the thread stacks inside the pause, but now with JDK 17, it was actually added in 16 already. The thread stacks are scanned concurrently, and that's the way to achieve those extremely low pause times. And if we look at the raw numbers, I have to use log scale here to be able to really see ZGC in the same chart as G1 and parallel. Still, it's a bit sad because it looks like parallel and G1 hasn't improved that much, but the improvements there are quite significant as well. As you can see, the P99 pause time for parallel has gone down 40 milliseconds from JDK to JDK 17, which is pretty great. And for G1, it's even more, like 70 milliseconds. And I mean, for ZGC, it's only 1 millisecond better, but it's a 10x improvement. So really impressive there. This is also pretty nice to see. So if we add one extra bar here, so the first runs are done with a 16 gigabyte of heap as the other charts that are presented. But if we add a bar with 128 gigs as well, out here to the right for each collector, we can see that for ZGC, scalability is not a problem. So the pause times aren't affected by the heap size. While for G1 G1 is still handling this good, but we still see a bit longer pauses when we grow the heap size. And parallel is having even a harder time, but still not falling off the cliff. So I think all the collectors do a really good job scaling up, but ZGC is built with this in mind. So scalability and low latency is really what the aim of ZGC is. So the last chart is footprint. This time I am using Spec JBB 2015 and looking at the peak memory overhead during a run. As you can see, parallel is doing good, has been doing good all along. Very predictable memory overhead. They have a few marking bitmaps that take up memory. They have a card table. But since no work is done concurrently, it's very predictable. As you can see in JDK 8, when all the remember sets were kept around by G1, the overhead was quite big compared to what was actually needed. So when rebuilding the remember set concurrently in 11, we're able to push the memory usage down 300 to 400 megabytes, which is very impressive and good. Looking at ZGC, you can see that it has the highest memory usage or memory footprint in this benchmark. And this is one of the things that you might have to pay to get those really, really low latencies. You have a bit higher memory overhead, but as you can see, the memory overhead is going down. So there is work going on here to improve this even more. So now you've seen a bit that all the collectors get good care and are improved. So G1 is very GC in OpenJDK is very much live. So my last slide, if you want to stay informed and know what's going on, we have a few resources that I want to highlight. As part of the JDK 17 launch, Oracle launched a new developer portal at dev.java. So I really encourage you to go there and check out a lot of good resources for Java developers. And if you're interested in news and views from the Java team at Oracle, you should check out insider.java, where you can find blogs, presentations like this one, and JEPs and other things from us engineers at Oracle working on Java. A lot of good information there as well. If you're interested in joining the discussions around what's what's going to be implemented and suggest things. You can join the mailing list discussions on openjdk.java.net. If you're interested in looking at the Java code, so the JVM and the JDK, it's all now available on GitHub since a few years. So just head over there and check it out. Or if you prefer your news through Twitter, I encourage you to follow at Java and at OpenJDK. Some good information there, basically sharing things from inside Java and stuff like that.
Thank you very much, Stefan. I think we just have time. I mean, yeah, we're slightly running out of time. Just if you can quickly answer this question from Raul.
Yeah. Yeah. Slide 20. Let's go back to. Yeah, I mean, if so, yeah, I guess you see it. I don't have to put it up. I can do it. Yeah, I mean, we don't provide any real-time guarantees like that. But if you want to have something, or if you want as low latencies as possible with Java, I think using ZGC is a very good choice. I don't see any other collector that would work better, but you need to test it and to know that you trade away some throughput and possibly some footprint to achieve those low latencies. But yeah, I think it's a good choice.
Super, thank you. Let's move on to the next presentation for today. Charlie, you're up. Let me add you to the stream.
So how much time do we have, Anthony?
That's a good question.
I was going to give you some flexibility. If it looks like we're a little short on time, I wanted to give people plenty of time to answer, any question, for Stefan to answer any questions. We can always schedule me for a later date. I also want to give time. I don't want to see people leave and lose their opportunity to
sure.
These licenses from IntelliJ.
I mean, if you can, if you can wrap it up in 30 minutes, I think we're super good.
Okay, we'll see if we can do that. All right.
Thank you. Sorry for that.
I'm assuming you're seeing everything okay.
Nope, we're not. Please share your screen.
That's actually where I'm at.
All right.
Let's see.
Yeah, it should be in the control panel at the bottom of your screen. At the bottom.
Yeah, it should be at the bottom.
Yes.
You see it now?
Nope.
No? Okay. I may have to change some things here yet.
Okay.
Anything now?
No.
No? Okay.
Have you tried sharing your whole screen or just an application? Have you tried both?
Yeah, I tried both the entire screen, the window. I take it that doesn't show up.
It doesn't.
Evidently not.
Nope, not for now.
Let me try switching over to a single monitor.
Mm-hmm.
take it that's still not showing. Not seeing
Nope.
that?
No, nothing. So the way that we would see it in the StreamYard panel, we will see another stream. So this is the way it's being represented.
Maybe we have found a bug.
I don't know. Kind of weird.
Yeah, I've tried it multiple ways here.
Okay. What is your OS? Is it something that you could change? Change computer? I mean, join from another computer. I don't know if
I'm
it's
on
possible.
Mac. I'm on Mac OS.
Okay, it should work fine.
I don't run a Windows machine. Haven't for over 20 years.
That's all right. That's all right. That should work fine from Mac. I was afraid that you were about to answer Linux or something. So I was. Sometimes support is not optimal. What could we try? We can't hear you, Mary.
Sorry,
Yes.
yeah, I muted. But which browser are you using, Charlie?
I'm using Chrome.
Yeah, Chrome should work. Yeah.
Maybe try to rejoin. I mean, just close everything up and rejoin. I mean, and restart Chrome. Yeah, and
No, it's
rejoin.
interesting. I get this message in Chrome that Chrome has lost permission to capture your screen.
Yes, accept. And I think
I'm going to change some stuff here.
Yeah, I think if it is the first time that you're sharing your screen with Chrome on Mac, it will Chrome will need to be restarted after you change the settings on Mac OS to allow Chrome
to
take control. So yeah.
Okay. Yeah. Well, let me log out.
Cool. And meanwhile, we'll try to run the licenses.
Okay. All right. Sounds good. Hopefully, be back in a few minutes.
Sure.
Okay.
Thank you.
Okay.
Yeah. Go ahead, Mary.
Oh, you know what? In my case, I cannot tell who the folks are who are actually present, right? To be selected. That's the only thing. We normally run our meetup, using WebEx, which then I can tell who's there.
Yeah, that's right.
Here I cannot tell. I was going to suggest if folks can join us on October 28th with the FUJI tour. We'll be having in-person and hybrid, but we'll run the same raffle the same way. And then, if you want to be participate in the raffle, can you all join back in October 28th as well? Then we will, add your names there too. So yeah.
But you know what, Mary? Let me try this idea. This kind of a last-minute idea.
Sure.
Why not ask the current participants following us live to just say, just type in the chat ChicagoJUG or ChicagoJUG, and then the two first to type MontrealJUG and the two first to type ChicagoJUG would be winners. Let's see.
Sure. That will be good too. Yeah.
Yeah.
Yeah. Let's see. So you just have to. Anybody wants to be, in the drawing right now.
All right, Vasily, boom. License for you.
Ursula.
All
right. I see Ursula. Cool.
Yep. Ursula too.
Yeah, and then I also got Kamran.
There you are. You've got your two winners for
All
Chicago.
right, we got our two. Yeah, thank you.
All right,
thank you, Ursula.
There it is.
Thank you, Kamran. This is easy. Thanks for the great suggestion. Otherwise, I was gonna run the spinning the wheel. Yeah, but this works too. Thank you.
Maybe I don't know how we're going to get the coordinates. So all right, for the MontrealJUG, I've got I got Vasil was first, and then Vasil and Gustavo, I think, were the two firsts. Please, if you have I don't know. Please let me know your coordinates. You can just send DMs to Twitter or on Slack, or just write an email to info@montreal.jug. Well, you know what? Yeah, let's do that. info@montrealjug.org. So that will be the email. And I don't know, how do you want to proceed, Mary, to find out their
Sure.
coordinates?
No problem. I normally would ask folks to private direct message me on the meetup.com, or if you're on Discord, also message me on Discord too. So either way. So yeah. Let me see. Yeah. Let me kind of post the Discord. I have so many windows. It's kind of sometimes a little slow in kind of getting all of our stuff out. And I'll give my Discord invites. Okay, folks. Too many things going on. Let me grab my stuff here. Okay, so CJUG Discord, if you'd like to join. Oops, wait, no. What am I doing? I guess it's the wrong thing. Actually, nope. I guess my system is slow too. I cannot actually delete that, right? Okay, well, I copied, but that didn't work. I guess my copy didn't work. There's been some issue with my keyboard in here.
Maybe send it to me over on Slack, and I will paste it.
Sure. Okay. Let me do this. Okay. That might work too. Okay, again, CJUG Discord. Here we go. I was like typing, copying,
yes.
Typing, and then So now it gets what? Okay.
Good.
Yeah. But I could not actually remove that other ones because it's going to be confusing on the chat there.
Yeah, but yeah, you're right. I don't think we can.
Yeah, we cannot, but that's all right too. That's a wrong thing.
It's pretty obvious.
Yeah, some previous buffer get copied in. Yeah, so I guess that's the challenges. I don't know how we can kind of change, right? I mean, we're like so busy today. I have like 10,000 different things. I like to be able to partition all of my desktop, for doing different things, accordingly. But now, in my Chrome tab, everything's mashed together. So yeah.
This is a big day, actually. Even presentation-wise, there is the second day of KubeCon happening right now, but I started 1 hour ago. So yeah, it's definitely a busy day.
Yeah, very busy. Exactly. That's what I'm doing. I'm actually speaking tomorrow at KubeCon, but it's at the virtual booth. So yeah.
Oh, nice.
That's why I was busy. So kind of had to be busy and quickly come up with some title. You can tell as advocates, we just like, okay, let's do a talk, and we'll be ready the next day. So, but yeah. So yeah. So this has been awesome. This has been great. Yeah.
Yeah. So far, so good. I mean, hopefully, Charlie's going to
Charlie can get it.
And you know what? I couldn't help but think that it's kind of October is. September was the month of Java 17, and October is kind of the month of OpenJDK. With our two presentations today, I think you've got Pratik coming and talk about Azul. And we also have Microsoft, Bruno Borges from Microsoft come and talk about their own JVM. So that's definitely some coincidence around OpenJDK.
Exactly. And I was almost going to also suggest too, because we are all friends, right? All of our JUG communities. So the Garden State JUG, New Jersey, right? And they are New York with the New York group too. They are actually going to have a talk, I believe, tonight, this evening. I'm going to advertise for them, Java 17. It's actually by Billy Corando. So folks can also join that. So yeah.
That'd be nice.
Yeah.
Hello again, Charlie.
Charlie, you're back. Good.
We can try this, or if you want to, Mary, I just sent you an email saying this machine's being pretty cranky. If you want to reschedule, that's fine with me. I know we're getting kind of close on time.
Sure, that will work too, in case, right? Because now there are technical difficulties. So
yeah, and that'll give me a little more time to add some more. I can add some more interesting things in there, and what I already have. So
sure. Yeah, I think that will work for us, we can, we'll find some time, and yours will be a more lightning talk, right? Smaller.
Yeah, mine was kind of designed to kind of jump around all over the place. Some interesting things that I've run across that.
Sure.
So a lot of them are things that people kind of get tripped up over, or maybe didn't know, but I didn't realize that. That's good. That's actually useful to know.
Yeah, I believe so. Yeah, okay, that will work for us. How about you, Anthony, on the Montreal JUG side?
Sure. I mean, yeah, well, yeah, definitely. Yeah, we could do that. That sounds like a plan.
Yep. Okay.
Yeah, and I can work with the two of you, and we'll get something scheduled.
Okay.
Yes.
That will be good too.
Let's do that.
Yeah. Okay. Sounds great.
Yes. So nice to have this. Nice to have this event. We also have our winners for the licenses. Thank you, Stefan. Thank you, Charlie. I'm really sorry, but things happen. It's live. But yeah, let's sync up together and let's reschedule for another time.
That's right. Yeah.
Yeah, we'll try things out a little ahead of time so we don't run into these little gremlins that are bugging me here today.
Yeah, they happen all the time. Yeah. So yeah. And thank you so much, and thank you so much again to Stefan for having been a great talk.
Thank you for having me, guys. It was a pleasure.
Okay then. All right. Wonderful. Yeah.
Bye then.
Everybody have a good day or good evening.
You too.
Yeah. Okay.
Bye-bye.
Bye-bye. Bye-bye.
Bye.